Thank you for this nice opportunity. This time I will talk about our GAMDAM glacier inventory. And the GAMDAM means glacier area mapping for discharge in high mountain, high Asian mountains. And this map shows the high mountain age here. And this is China and Nepal and Mongolia. And blue dot indicates glacier map, which we generated. It is a little bit old story. Our project has started in 2011, more than 10 years ago. And I finished the update in 2018. So today, I will talk about our project from its beginning to its end of update. And first, I would like to introduce Graham's word. Maybe young researcher knows is Graham Cogley Award of IGS. Unfortunately, Graham has passed away before checking our updated GAMDAM glacier inventory. But during his lifetime, he encouraged on our work. In 2015, IUGG meeting was held at Prague. I attended Algae working group meeting. It was first time for me. And LGI means the land of glacier inventory, that is collection of digital outlines of global glaciers. And the working group tried to collect and improve the glacier inventory. In that meeting, he was an organizer. Graham said about the task of RGI working group, we are not doing glaciology, but we are doing work that is essential for glaciology. I could not catch his words exactly at the time, but it was impressive for me. So after coming back from IGG, I sent email to him and confirmed his word because I would have liked to report his word in Journal of Japanese Snow and Ice Society. Yes, I completely agree with his word. And I know that there's some jokes included in his word, not doing glaciology. But it is also true that glaciology often disappears during making process of glacier inventory. Delineation of glacier outline is not glaciology, it's only simple work like a machine, but the accuracy of the inventory directly affects the result. But anyway, today's talk do not include so much glaciology, so please feel easy to listen. And before going to the story of glacier inventory, I will talk about my past studies. My first field observation was studied from Tolorpa Glacial Lake in Nepal, Himalaya, and this lake was already large with 3 kilometers in length when I started observation, and now it's 3.5 kilometers. We use rubber boat, a rolling boat like this, and those boats have no motors, and I had to row the boat with oars all 3 kilometers. At this lake, just 10 a.m., very wind start to blow. So after observation, when I was coming back to Terminal Moraine, I have to roll the boat against very wind. It was physically very hard. And next field work, the debris covered glacier. This is a Kump glacier. I took this picture in 1995 using a film camera. In this field work, it was not necessary to roll rubber boat, but stones and rocks on the glacier all loose because glacier ice is melting and the rock debris. So I always fell down when I went to glaciers. but sometimes some dogs came together with me, so it was not a bad time. So next, I had a chance to calculate discharge from glaciers in one Nobel basin in northwest China, which include many glaciers, the blue dot. And if we know fluctuation of specific discharge at each altitude, we can get total discharge from glaciers by multiplying glacier area distribution. At the time, we had no round of glacier inventory, so we made glacier inventory ourselves using satellite imagery. Then, the altitudinal glacier area distribution was obtained by extracting digital elevation model. When I saw my result, and I surprised that the calculated total discharge was much larger than observed data. First, I did not know why they are so large, but closely looked the calculation process, I found there was a glacier at very low latitude. In the simulation, large amount of meltwater came out from this part because of higher temperature. So actually, this was not glacier, but it was frozen lake. And so I have excluded the frozen lake, then I could get a reasonable result. So if the glacier inventory includes non-glacier area, it would lead to the wrong result. This is the first motivation to make accurate glacier inventory. And second motivation came from this paper, Gabel et al. 2011. And this paper has analyzed the relation between glacial lake evolution and glacial mass changes. It was very interesting analysis for me. What I would like to focus here is the target region. As shown in this figure, the target region are not continuous area, but covering various kinds of climate area, such as summer accumulation type and winter accumulation type glaciers. So, if there are accurate glacier inventory like this GAMDAM glacier inventory, we can get seamless distribution. Then I thought that accurate glacier inventory is necessary. So then, in 2011, we started our project. First, I have set our target area, this white line. Usually, range of glacier inventory has set in some basin, a pink line, or within a country. At the time, I worried about the edge of the target area do not cut the ridges, because the glaciers usually distribute at high elevation ridges, across ridges, or watershed boundary, like this figure. So if we set the edge of the target region at mountain ridges, glaciers are separated at the ridge. Then if we combine two different inventories, there must be overlap, or missing area like this. Then I have extracted the target area to where we can say that there are certainly no glaciers. And at the time, I could not care the work amount to complete the glacier inventory. Now I wonder how we could have targeted such a large area. And in the first meeting, we decided that we will delineate glacier outline by manual digitizing. Because there are many debris-covered glaciers in high mountain Asia, we can extract glacier area with debris-free part by band ratio, but we thought that we'd like to apply consistent method for whole our target. Then that we can unify the quality of inventory. So we need several researchers who can digitize glacier outline. Then total 14 people involved for GAMDAM project. The project fund was attached for only 3 years. Not only glaciologists, but also other specialists, for example, ice core, geographers in volcanology, traced the glacier outline. And I have been mainly did field work and do not familiar with GIS at the time. So Dr. Nuimura has designed this project well and established procedure manual of glacier delineations and planned delineation tests by several members and checked large amounts of glacier polygon files. And now I have to talk about the naming of our project. We named our project GAMDAM. The name came from Japanese animation GAMDAM. And when I was childhood, it was very popular in Japan. Even now, there is a lot of fun. And now, still now, you can meet life-size GAMDAM in Yokohama near Tokyo. But when I introduced my project name to one of a Japanese metallurgical researcher, he said, it doesn't show up in a search because the GAMDAM animation is so popular. Actually, when I search my word on only GAMDAM in Google, the GAMDAM animation came at upper line, although the spelling are different. So when you search, please search GAMDAM glacier inventory, not only GAMDAM. Then you can reach the data set of GAMDAM glacier inventory in Pangea. And I have evaluated work amount before starting our digitizing. The glacier area are different at each Landsat scene, Paslow scene. So the work amount of glacier delineation is also different at each Paslow scene. Then I estimated very rough amount of work at each scene using snow cover condition in Google Earth. So, and the estimated work amount was classified from 1 to 10 at each scene, and I decided the unit was Zaku. Zaku, Z-A-K-U. Zaku came from the name of mass-produced robot in GAMDAM animation. In my first estimation, there are 223 Paslow scenes of target, and based on my subjective rough estimation, total amount was about 700 Zaku. So if we want to finish within 1.5 years by 5 persons, 8 Zaku have to be finished per person per month. But it's only estimation. Reality is not so easy. So I would like to explain how to use Zaku. I had a meeting once a month. At the meeting, we usually start to ask to each member, how many Zakus did you finish? And then one by one, the member used to answer only 1 Zaku, or this month I only did 1 Zaku, but the next month I will finish 10 Zaku. In this way, we often use this unit Zaku. And one day, Nuimura-san reported to me that I found the total glacier area suddenly increased since last week. I don't know why. And Nuimura-san searched our shapefile data in a server and found a big polygon with question mark shape occupying a Tibetan plateau. When I heard about that from Nuimura-san, first I seriously thought some hacker entered our server and made a prank. Then Nuimura-san asked to all GAMDAM member one by one. Do you know the polygon with question mark shape? And one of our members, Omiya-san, answered, "Oh, it's me. I could not well identify glacial outlines in this area, so I drew this. This shape is nice, isn't it?" It was not the work of hackers. In this way, GAMDAM project has been pushed forward. First delineation tests by different members were carried out at several locations in order to read the correct digitizing. In the upper part, the glacier is surrounded by steep walls. One member brown line included steep walls, but closely looking at Google Earth, rocks exposed at the wall. So brown is not right. In the raw figure, we tested raw part of debris-covered glaciers. As you know, debris-covered glaciers are decline surface elevation, and only steep ridge lateral moraine stands at both sides. There is no ice inside in moraine, so we should exclude from glacier area. So above these lines had mistake. And this figure shows the median elevation averaged at each 0.5 degree grid based on merged glacier polygons after 2 years and after 3 years since project started. 2 years after, about 60% area are already covered, but we did not finish Pamir, Bhutan Himalaya, and Hendanshan. Hendanshan was especially tough because of a lot of cloud cover and seasonal snow, but members were bold enough to digitize. And after 3 years, all part are covered. It seems good, but actually they required revision. Then March 2014 came. The project was finished and project fund was finished and members have gone away. Fortunately, all members could get a job at some university or institute. Then from April 2014, second stage of this GAMDAM project has started with members. I continued to revise the inventory because of my persistent personality. And by the way, selection of satellite imagery is the most significant work for glacier delineation, even manual or automatic band ratio method. In order to get clear glacier outline in satellite images, 3 less are required. That is less cloud, less seasonal snow cover, and less shadow. In the high mountain Asia, a lot of area affected by the summer monsoon, and this figure shows the summer precipitation ratio to annual precipitation, and red color indicates higher summer precipitation ratio. So almost east side of high mountain Asia has much precipitation during summer. The monsoon bring along cloud and snow, and it is tough to find clear satellite images. Then winter image is preferable in terms of less cloud and less seasonal snow in high mountain Asia. So at the first stage, we collected winter images. But as you know, shadow cannot be avoided in winter images. We missed shadow part in the first stage. So in the second stage, basically, I selected cloudless, snowless summer images. In this figure, Color indicates acquired season of Landsat images used to delineate. Red one indicates summer image. Before update, we used summer images of about 70% of glacier area. But after updating, I used 95%. Yes, I could not get clear summer images for 5% of glacier area. Here, you can see that I used non-summer images, yellow and blue. And so in the next, I will show you that how I selected images for these regions. In this scene, I have delineated glaciers using different images across the ridge. I digitized upper glacier with yellow line, this one, using no shadow summer image. But there cloud cover at the south face. So I also selected winter images for glaciers at the south face and digitized by pink line. So mainly I used non-summer images for glaciers at south face. Here the color shows the number of images used to delineate, and total number of Landsat images used to delineate was about 350 before update and 450 after update. In the Tibetan Plateau, we usually use only 1 or 2 images, but in the Himalaya and Southeast Tibet, Himanshan required many images. Maximum number is 9 here. And here is the 9 Landsat images that I used for this pass-through scene. All summer images have part of cloud cover, and also winter images have part of snow cover. In avoiding cloud and snow cover area, I have found clear glacial outline and digitized. And actually, I also use images with a data gap. And the Landsat 7 images has data gap stripe line after May 2003. So this image has data gap, but at the middle of the image, there are clear images, so no gap. And I found clear glacier outline here, so I could digitize these glaciers, light green one. And in this pass-through scene, I also had to use non-summer images for glaciers locating at north face. Yeah. Of course, there is shadow, but I could not find clear summer image for these glaciers, so this location needs revised in future. It seems there is a glacier in shadow. Yeah, and this figure shows the median elevation before and after update. Those are averaged at each 0.5 degrees. After update, some glaciers, glaciated grids disappeared, probably due to the removal of seasonal snow cover. Overall, it seemed there is not so much difference before update and after update. Using these median elevations, I have estimated optimized precipitation at each median elevation. So this is the optimized precipitation based on the previous median elevations. So I will explain how I estimated optimized precipitation. Usually, free atmosphere air temperature, our reanalysis data set correspond well with observed one in mountain area. but precipitation do not correspond well. So in this method, we assumed that median elevation is equal to ELA, equilibrium line altitude. And using mass balance model, precipitation at ELA was estimated so as to glacier mass balance become zero by adjusting precipitation amount. This method already published at the cryosphere in 2015. And here, important thing is that if median elevation is lower than actual due to including seasonal snow cover or something, optimized precipitation become larger than the actual, because at lower altitude, larger ice melt, so larger precipitation necessary to compensate glacier mass. The optimized precipitation based on before update was much larger than actual, especially West Altai and West Himalaya, Hindu Kush, and Henuanshan. This is because seasonal snow cover is included in the Altai and Henuanshan, and the higher steep part was missed in the Hindu Kush. Then before update, glacier polygon in those regions had lower median elevation than actual. After update, optimized precipitation became reasonable values. In this way, optimized precipitation can be used to check the glacier map is reasonable or not. And Herreid and Pellicciotti 2020 has generated global map of debris-covered glaciers. And they published Nature Geoscience, and it's great work and a huge data set. They did not use LGI global glacier inventory as is, but they updated LGI and obtained more accurate debris-covered distribution. And they selected most recent satellite images, which has less cloud and less snow cover, then identified land is not glacier, which was defined that LGI false positive FP, and also they digitized manually glacier area missing from the LGI, which defined as false negative FN. That is mainly debris-covered glacier tongue. I thought the FP and FN data would be suitable to evaluate updated GAMDAM glacier inventory. So this figure is false negative generated by Herreid. Red one plotted on updated GAMDAM glacier inventory. In this area, false positive polygon are gathering. So next I'll check. And here is a detail of Tianshan, almost false positive polygon, red one. Do not overlay with GAMDAM glacier polygon, light blue one. And we can find small overlay, but those FP area locates at glacier terminus. So they indicate that recent glacier terminus retreat. And next is the false negative area, in other words, glacier area missing from the LDI. There are many purple dots at Karakoram. So I have checked the detail. And this is one of the examples of false negative in Karakoram. This picture came from Google Earth. Left one shows the status in 2010, and right one is at 2013. Within 3 years, the terminus location has advanced. It seems such event. Many such events occurred in the Karakoram, so around here, false negative reflect such event. And next one is Nepal Himalaya, east of Nepal Himalaya. There is a large FN area. Google Earth shows that there are ponds surrounded by ice cliffs. So I also think that the FN should be included as glacier area. So this is my mistake. Okay. And in the mountain region of Afghanistan, there is no false negative area. Herreid didn't point it out, but in this region, there are a lot of rock glacial-like debris covered ice. And before update, red one, I have included those rock glacier-like area, rock glacier-like area, as shown in red color. But when I update, I have excluded those areas as rock glacier because the surface looks very flat. But take a look at Google Earth image, this one. These are ponds. There is a pond surrounded by ice cliffs. These are ponds surrounded by ice cliffs in this area. So now I have excluded this area, but I wonder, I should have included this area as a glacier area. Actually, it is difficult to judge debris covered glacier and rock glacier. Yeah, so this is the last slide, and this is summary. We have generated GAMDAM glacier inventory by manual method. And so the conclusion is it's difficult to reach perfect glacier inventory, especially for debris covered glaciers. So recommendation is that when you use glacier inventory for few or several glaciers, please modify yourself. And finally, I'm very looking forward LGI 7 completion. Thank you. That's all.
Thank you so much. Such an important area for water supply in so many places. And fantastic to learn a little bit about Japanese anime as well on the way. Our talk. I'll be able to. I have two nephews who have lived in Japan for well until this year. So they're always talking to me about anime, and I know little about it. So, if anyone has any questions, perhaps you could pop them onto the chat. Yeah, while people are, Frank, do you want to go ahead? Got your hand up.
Of course, thank you. Thank you very much for this background that I was never aware of, and that is actually good to know. We were always completely unclear how is it at all possible to do within such a short time this huge amount of work. And yeah, so I see you also had some co-helpers, and that certainly helped a little bit. And of course, I'm happy to confirm all the problems you showed. I just want to mention, of course, in the meantime, we have Sentinel-2. And that's quite a cool thing when it comes to clouds, in particular in these very strange regions you showed. What I can confirm is that over the past, 7 years with Sentinel-2, the problem is still the same. So we would have maybe not 9 different scenes, but at least 8 to get things mapped there. So there is actually no better way of doing it and pick each individual glacier from each individual scene where you can see it. So this disaster has not changed at all at the moment. So thank you very much for your very diligent work there and try to get out the best glacier extent of these many scenes. It's much appreciated.
Thank you. Yeah. I cannot write a paper in this kind of detail. So this time it's a chance to speak. Yeah.
And just to add, for the RGI-7, we used for entire high mountain Asia GAMDAM 2.
Yeah, I know the Fabian.
Yeah, it's the best data set we have actually, and now to know that you have put so much work into it, I think there's no other way of using it. So the High Mountain Asia in RGI-7 will be GAMDAM 2.
Thank you.
As we name it. Thank you very much.
Oh, welcome. Thank you. Thank you for listening. I'm very happy to meet you this time.
Ian Evans, I think your question may just have been answered by Frank, but is that right?
Yeah.
Ian has put a question onto the chat, but do you want to? You might need to unmute yourself, Ian. You're still muted.
How does GAMDAM relate?
You're muted, Ian.
Yes.
There we go.
There we go. Yes, I still wasn't quite clear. I should know this, but did GAMDAM feed into RGI so that all RGI in this area is from GAMDAM, or just what is the relationship between your work and the rest of RGI?
Maybe Frank knows well, but in now the RGI is version number is 6, and the before updated version has included part of the before updated one was included in the version 6 at present one, and next after updated version will be included in 7.
Okay, thank you very much.
So in RGI 6, Graham Cookley had compiled all the best data sets he found. So it is, for example, the Chinese glacier inventory, the second one that had been used for a large part, and then different inventories from all kinds of sources. For example, GAMDAM 1, and also Isimode inventories and some other colleagues. So it's a completely wild mix of sources for RGI 6. And for RGI 7, it will, maybe apart from few individual glaciers, it will only be GAMDAM 2 for entire high mountain Asia.
And if I may, just to add to the process, so RGI 7 and future versions, RGI 7 and future versions are created directly from the GLIMS database, and GAMDAM 2 is in GLIMS. And so going forward, that's sort of the flow. New data go into GLIMS, and then the best for a particular time period are extracted from GLIMS to create an RGI version. So,
thank you.
Sorry, can I come back on that? I understood that you still have problems with GAMDAM 2 with this, because the examples you showed, they seem to me very much glaciers that you said might be called rock glaciers. There seem to be plenty of lakes, where you have those lakes, for example,
Still we have problem. Yeah.
So there are still problems. So are you going to correct those problems in maybe GAMDAM 3 or whatever?
Yeah, this work was so hard for me. So I finished the work anyway. Yeah.
Yeah, you've done a lot. Thank you very much and very interesting presentation.
Maybe just to add, Ian, we are just discussing about possibly populating a further or an already existing field attribute of the glaciers that was present in RGI-6. It is called form. And we have not decided it yet, but there might be a possibility that we assign numbers to existing polygons, coding specific glacier types. So there might be one for glacier and ice caps, one for perennial snowfields and ice patch, but also for ice debris landforms. So fully agreed, it is simply not possible in many cases to say, oh, this is our rock glacier, let's kick it out. And this is just a debris covered thing. So it's really, as Akiko has described, it's a homogeneous transition. And so you can also not say this is right or wrong, but you might just assign a note that please be careful, this is something in between. And then people can select based on the attributes if they want to include it or not. But we are not yet this far because this required some manual work and it might be only for RGI 7.1. But at least, we try to deal with it to some extent and will decide soon what we will do.
Thank you. Thank you, Frank.
Thank you.
Thank you very much to everyone for contributing to that discussion. Are there any other questions at all from the audience? Okay, I don't see any. So I think it comes on me simply to say a huge thank you to Akiko and also to just advertise next week's seminar, which hopefully will appear very soon. Yeah, I'm not sure that worked. Is that the next week's seminar slide? It's just vanished off my screen. Next week's seminar is 2 sea ice talks, one on the Southern Ocean mapping platform by Sean Cho, and one on bridging the scientific and indigenous communities' understanding of sea ice change in the Arctic by Andy Mahoney of the University of Alaska. So thank you very much indeed, Akiko. That was a fantastic presentation from a really important area. So thank you very much. And thank you very much to the audience and for all the questions. And I don't know what I'm sharing, so I'll stop sharing because I'm a bit worried. Thanks very much to all.
Thank you.
Bye-bye. Thanks.
Bye.
Thank you for getting up so early for us.
Bye, thanks.